So good evening, students.
Good evening, sir.
So today we will start about the organic chemistry. Okay. So today we are going to start about the organic chemistry. So what is organic chemistry? We are going to start about very basic one. So what is organic chemistry? Do you have any idea?
Study of hydrocarbons.
What?
Study of hydrocarbons.
Okay, then what else? So organic chemistry and there some basic principles and techniques. So that only we are going to see today. So you could see the board clearly, right?
Yes, sir.
So when you're seeing that organic chemistry, it's mainly because of the carbon. The backbone behind your organic compound is carbon. So why we have taken this carbon, it forming a plenty of compounds like that? Because the carbon atomic number is 6. You know that when the ground state electronic configuration is 1s2, 2s2, 2p2. So it has very smaller size. It has one s and p orbital only. It doesn't have p orbital also, but it has a small property that is called catenation. Catenation means it will form a chain like that. Okay. So because of the catenation property, it will form a multi number of compounds, and also it exhibit a valency of 4. So it can able to form a 4 bonds. It can able to form 4 bonds. With this property, so we are the carbon which can combine with hydrogen means hydrocarbon, which is combined with the halogen means halo uh, haloorganic compound. O is built alcohol like that. Whereas the basic backbone is your carbon. Okay. So mostly you have carbon and hydrogen. We know that the carbon which is from the non-metal, right? P-block element. But it also forming a branch of chemistry. That is why we are call it as organic chemistry. Now, first, when the organic chemistry started means, who is that person? He has taken ammonium formate, ammonium cyanide. So when heated, you could end up with the urea. The first organic compounds in this rollers. So the Brazilian Swedish chemist proposed that a vital force was responsible for the formation of organic compound. So the Ola synthesized the organic compound, urea form an inorganic compound. Okay, when you take the ammonium cyanide, when you're heating, it end up with the urea. So the carbon containing compound, carbon and nitrogen containing carbon. Now we are going to see the tetravalence of carbon. We have seen the hybridization, no? Again, we will see that. Okay. Have you seen that hybridization? Methane, ethane. Yes or no? So, if you're seeing the valence bond theory, the valence bond theory tells that the valence electron only involved in the bond formation. As for that, the p orbitals are 2 electrons. You have only two unpaired electron. So carbon can able to form a 2 bonds. Whereas we know that many compounds which is having the tetravalency. To account for the tetravalency, when you have the carbon in the ground state, it has 1s, 2s, and 2p. 1s2, 2s2, and 2p2 in the ground state. This is 1s orbital. This is the 2s orbital, 2p orbital. It will become 1s. Okay. So 2px, 2py, 2pz. When it go to the excited state, so one of the electron get excited. So when you have 1s and 2s and 2p. 1, 1, 1. So now you have the 3 unpaired electrons. So it can able to give the 3, 4 tetravalence. It can account for the tetravalence, right? It can account for the tetravalence, right?
Sir.
So now, so what you could say, no, when the s orbital combined with one more s orbital, so you know that the s orbitals are spherical in shape. So when it combined with one more s orbital, it will form SS overlap. It gives the sigma bond. It will give the sigma bond. Suppose one s orbital and one p orbital overlapping means, and it will give sp overlap. It also gives sigma bond. And another thing, one p orbital, the same direction, one more p orbital. If it is overlapping, it will give another sigma bond. So all are taking place in the bond axis. So when the overlapping takes place in the bond axis, it always leads to form a sigma bond. Suppose this is your bond axis, mean when your p orbitals are perpendicular to the bond axis. So when it involves the sideways overlap, it gives the sigma bond. So the p orbital overlap will give the pi bond. So if you are taken this is a Z means X and Y will form a pi bonds. Okay. Okay, students.
Yes, sir.
Now,
Yes, sir.
when the s orbitals are spherical shape, another s orbital is spherical shape. When the two s orbital overlap means, so you will get some type of overlapping, and you will get the same. You will get one type of bond. Look here, when you have 1 2s orbital and 3 2p orbital. So the p orbitals are dumbbell in shape. When the hydrogen is overlapping means the p orbital will give one type of shape and s orbital will give one type of shape. So what you are expecting, the 4 bond must be different, isn't it? Because SS overlap means So 1s orbital of hydrogen and 2s orbital of carbon overlapping means spherical will give one type of bonding, and p orbital double and s orbital spherical will give the other type of bonding. Whereas when you are seeing that carbon tetrachloride or carbon methane, all the four bonds are same. To account for that, so one person told that when the carbon, the 2s and 2p orbital, which involved in the hybridization, that means the nearly having orbitals or energy, the same energy orbitals, which undergo hybridization, it will form a new set of orbitals which are equal in energy and they are oriented in the space as apart as possible. Okay. So when you are taken, when one s orbital and 3p orbital is overlapping, one s orbital and 3p orbital. So it gives sp3 type of orbital, which is having 1/4 of s character and 3/4 of p character. So it gives the sp3 orbital, which are having 4 sp3 orbitals. So they are having equal energy. So if you are thinking this will be the energy, 1s energy, 2s energy, 2p energy. So when it undergo excitation, the 2s 2p distance will be very less. So that so that so you have 4 sp3 hybridized orbital. The 4 sp3 hybrid orbital, the electron have one unpaired electron. Now the carbon which is having four sp3 hybrid orbital. I told you what is the simplest example for the hybridization. When you take 10 ml of your white ink and 10 ml of your red ink, when you are mixing together, it will give 20 ml of pink color. So the pink color is not neither red nor a white, but it is a new color, okay, which is originated from the red and white. It is originated from red and white, right? So that new set of orbital which will be equal in volume. That's why when you are taking 1 and 3, it will give 4. But they are
Tell me, when the overlapping taking place in the bond axis, it will give what type of bond?
Sigma. Sigma bond.
Sigma bond. When it overlapping take place perpendicular to your bond axis means?
Pi bonds.
That's all. Okay. So now we have two set of bondings. So other than sigma and bi bonding, you have delta bonding also. Okay. The delta bonding will give only d orbital. So now we are studying organic chemistry. We have s and p orbital. So we can get only sigma and pi bond. We will not get any delta bonding and all. So to account for the tetravalency, it was accounted on the shape and the bond angle, which was explained very easily by means of your hybridization. Is it clear, Pa? Is it clear? So what is the important things about the hybridization? When you are taking, you have to say the characteristics of hybrid orbital. What is the importance of hybrid orbital? Just tell me. What is the importance of hybrid orbital?
Any idea? சொல்லுங்க. Any idea?
No, sir.
Could you hear my voice, ma? All of you?
Yes, sir.
So any idea about that?
No, sir.
Now we'll see that. What is the difference between atomic orbital and hybrid orbital? What is the difference between your atomic orbital and hybrid orbital? What is the difference? You and me, huh? What is the main difference between your atomic orbital and hybrid orbital? Hey, you have to answer at least one or two. Very bad. நீங்க இந்த மாதிரி ஆன்சர் பண்ணாம இருந்தா எப்படி? At least you have to answer one or two questions, no?
Sir.
Hmm.
Sir, atomic orbitals வந்து two different orbitals வந்து mix ஆக போறது.
Two different orbital?
Mix ஆக போறது, sir.
Okay.
Hybrid orbital வந்து same atom.
Okay. So, simpler சொல்லலாமா? When you have the atom which contain the orbital, that is called? What is that?
Atomic, sir.
Atomic orbital. So, when the atom possessing orbital, that is known as atomic orbital. So, the atomic orbital is s orbital, p orbital, d orbital, and f orbital. That's all. Okay. Hybrid orbital means when the atom which undergoing hybridization, the equal energy orbitals will hybridize, it give a new set of orbital that is known as hybrid orbital. So when you are seeing so carbon having smaller size, intermediate electronegativity, 4 valence electron, and the ability to form a multiple bond, so it gives the structural complexity of your organic compound. So what are the factors that lead to carbon ability catenation? So due to the catenation property, which create chain, branches, and ring of carbon atom. Smaller size and the absence of d orbital in the valence level lead to strong and chemically resistant bond. So that point is as many as 4 direction form each carbon. The carbon ability to bond to many other elements, including oxygen, nitrogen, phosphorus. So it gives a polar bond, resulting in the greater reactivity, lead to chemical diversity of organic compound. So most of the carbon compound containing functional group, specific combination of bonded atom that reacted in characteristic way. That is the organic chemistry. So the atomic number of carbon is 6. Valence is 4. The electronegativity, the electronic configuration is 1s2, 2s2, 2p2. Okay. So what is hybridization? Hybridization is defined as a mixing of atomic orbital belongs to the same atom which is having slightly different energy, so that The redistribution of energy takes place between them, resulting in the formation of new orbital of equal energy and the identical shape. The new orbitals are known as hybrid orbital, and the process is known as hybridization. So this is what we have seen in that chemical bonding unit itself. So what are the important features of our hybrid orbital? The number of hybrid orbital formed equal to number of atomic orbital mixed. So you see one s orbital, 3p orbital mixed. So it gives 4 sp3 orbital. So the type of hybrid orbital formed varies with the type of atomic orbital mixed. If you are taking s and p, you will get sp. If you are taking s and p and d, mean spd. That's what. Okay. So it is not necessary all the off-filled orbital must be takes place in hybridization. Even filled orbital also participate in hybridization, or completely filled orbital also slight energy difference also participate in hybridization. The shape and orientation of hybrid orbital maximize overlap with the orbital of the other atom in the bonded. So அதை பொறுத்து தான் உன்னுடைய ஷேப்ஸ் இருக்கும். இப்போ நம்ம அடுத்து ஈத்தேன் மாலிகூல்ஸ் பார்க்கலாம். ஓகே, இஸ் இட் ஓகே?
Yes, sir.
Yes, sir.
So are able to understand? Are able to follow me?
Yes,
Sir.
sir.
Okay. Any doubts?
No,
No,
sir.
sir.
When you are taking ethane or ethylene,
Ethane.
now that 4sp3 will be the tetrahedral shape. And it will form overlap with the s orbital. It will give the tetrahedral. Now itself I will tell you how to see that. In the class itself, I told you when you are having a tetrahedral means two V's are joined together and two V's are in the plane. Okay, which will be lies in the same plane. That solid line indicate they are in the same plane. And one more line they will put like this. And then like this. So it indicates, so they are in the plane, in plane. So these two are out of plane. So could you see that what I'm writing? And this will be towards you. This will be away from you. So in the organic compound maximum, we are going to see this type of bonding only, because their tetrahedral shape means two are in the same line and one will be far away from you, one will be towards you. The towards you will be the thicket line and dotted line will be away from you. Is it okay? When you are seeing opposite to this dotted line, it will become a fan இந்த மாதிரி இருக்கும். இது dotted line you are seeing like this means the car உடைய டயர் இருக்கு இல்லையா, அதுல இருக்க பெண்டோ இல்ல ஃபேனோட ரெக்க இருக்கு இல்லையா, அந்த மாதிரியே இருக்கும். சரி, நீங்க பாருங்க, இதை பார்க்கும்போது அப்படிதானே இருக்கு. when you are hiding these three எப்படி உனக்கு தெரியுது? எப்படிமா தெரியுது? இதை மறைக்கும் போது how could you see? Three lines triangle மாதிரி தான் தெரியுது.
Sir.
ஆனா இது towards you, இது away from you. Is it clear?
Okay, sir.
Okay. So it lead to sp3 hybridization. When you are taking ethane molecule means CH3 CH3. So this atom going to be the hybridized, this atom going to be the hybridization. Look here, the carbon which is attached with 3 hydrogen and 1 carbon. So totally it will form 4-1. Please remember, in the organic chemistry you have sp, sp2 and sp3. Okay, that means sp means 1 plus 1 2, 1 plus 2 it gives 3. 1 plus 3, it gives 4. So 2 bonds around the central atom அப்படின்னு சொன்னா it's a sp. 3 bonds around the central atom அப்படின்னு சொன்னா sp2. 4 bonds around the central atom சொன்னா அது என்னது? It is
SP3, sir.
SP3.
Now I will write CH3, CH2, CH double bond, CH2. Now you tell me what is the hybridization of your molecule? What is this hybridization of this carbon? First one. Tell me what is the hybridization of first one?
SP2, sir.
Huh?
SP2, sir.
Why it is SP2?
SP3, sir. SP3, sir.
Huh?
SP3, sir.
SP3. Why it is SP3?
4 bonds, sir. It has totally.
So 3 hydrogen and 1 carbon. So sp3. So this will be wrong. And what about this?
SP2, sir.
sp2
Sir.
வேற யாராவது?
Sir, SP3.
SP3, sir.
Why it is sp3?
Sir, because it has 4 bonds in total. C is the
2
bond.
hydrogen and 2 carbon. And what about this?
SP3.
Hmm.
SP3 only, sir.
SP3.
sp sp
SP3.
sp3. Why it is sp3?
Because there are 4 bonds in total.
See, carbon always have 4 bonds. 4 atom. Bonded atom. Bonded atom. 4 bonded atom. அப்படி வச்சுங்க. அப்ப பாருங்க இது இந்த கார்பன் கூட எத்தனை atom அட்டாச் ஆயிருக்கு? For this carbon, how many atom attached?
3.
1 carbon, 2 carbon, and 1 hydrogen. Totally how much?
3.
Then what is the hybridization?
SP2.
For this carbon, for this
SP2.
carbon, sp2. புரியுதாப்பா? நீங்க ஒண்ணுமே இல்ல. You have to count the bondings. So here it was attached 3 hydrogen, 1 carbon, sp3, 4 bonded atom. This one 4 bonded atom. This one 3 bonded atom. This one 3 bonded atom. Now you tell me for this molecule CH2 double bond C, double bond C, single bond. Double bond. Now you come to here. You tell me what is the hybridization of this carbon? First carbon what is the hybridization?
SP2.
sp2.
2.
Okay. What about this next carbon?
SP.
sp. And what about the next carbon?
SP2.
For this carbon? For this
SP3.
carbon? sp3. For this?
SP2.
Last one.
S.
Yes. For this carbon, you tell me.
SP2.
This sp2. C triple bond CH. It attached to 1 carbon and 1 more carbon. Then what is that?
sp.
This one sp. So in this sentence I have written all type of hybridization. When you're taking the first carbon, it was attached 2 hydrogen and 1 carbon, sp2. For this, it has 2 carbon, sp. For this, it has 2 carbon, 1 hydrogen, sp2. For this, 2 carbon and 2 hydrogen, sp3. For this, it will attach 1 and 2 carbon, sp. For this, 1 carbon and 1 hydrogen, sp. So what you have to do, you have to see that whether the carbon which is attached with how many atom. அவ்வளவுதான் ஆர்கானிக் பொறுத்த வரைக்கும் இவ்வளவுதான் நமக்கு வரும். அதை தாண்டி எதுவுமே வராது. sp, sp2 and sp3 இதை தாண்டி we will not get anything. Is it okay? Is it okay va?
Yes, sir.
Then you have to calculate number of pi bond and sigma bond. Look here, here there is no unsaturation. That means there is no double bond. That's why 4 in the carbon பொறுத்த வரைக்கும் எத்தனை carbon how many carbon sigma bond, how many carbon pi bonds, and how many carbon hydrogen sigma bond. Okay, pi bonds na p orbital இருக்கறத ஃபார்ம் பண்ணும். எப்பவுமே pi bond க்கு வந்து carbon hydrogen வரவே வராது. Will not give like that. Okay, when you have the pi orbital or p orbital, then it will form that. Okay, now you tell me from this carbon how many carbon bond is there? 1, 2, 3. So 3 carbon sigma bond. So that is 1, 2, 3. And how many pi bonds? Only 1 pi bond is there because sigma bond, pi bond always exists along with the sigma bond. Okay, wow. Please remember, pi bonds always along with the sigma bond. அப்ப இங்க எத்தனை pi bonds இருக்கு? How many?
1.
கார்பன் ஹைட்ரஜன் பாருங்க, இங்க 3, இங்க 2 5, இங்க 1 6, இங்க 2 7. So totally 11 bonds. Correct and பார்க்கலாமா 11 bonds? Carbon 1 2 3 1 2 1 double 1 1 2. So 1 2 3 4 5 6 7 8 9 10 11 and 1 by 1. 3 5 6 7 8. Yeah, you made mistake. 8 plus 1 9, 9 plus 3 12. So you tell me for this compound, the next carbon, you tell me how many carbon sigma bond for this. How many carbon sigma bond? இப்ப சொல்லுங்களேன்.
5.
1 2 3 4 5. So 5 carbon sigma bond. And how many pi bonds? Carbon pi bonds. Multiple bonds. 1 2 3. Very good. How many carbon hydrogen sigma bond?
7.
2 3 5 6 தானே வருது. I am getting only 6. எழுதி பார்க்கலாமா? Carbon hydrogen 1 2 3 4 5 1 2 3 4 5 6 carbon hydrogen. Carbon 1 2 3 4 5 6. 6 carbon, sorry, 5 only. 5 bond 1 2 3. இங்க 2 pi bond இருக்கு. அப்போ 4 வந்துரும் கரெக்டா? பை பாண்ட்ஸ் பார்ப்பா. இது ஒரு பை பாண்ட்,
Yes, sir.
இது ஒரு பை பாண்ட், இங்க 2 பை பாண்ட் இருக்கு. ஓகே, so 3 + 1 4 பை பாண்ட்ஸ். புரியுதா? Is it clear?
Yes, sir.
Sir.
Shall we move further?
Yes, sir.
When you are taking the organic compounds, the organic compounds can be classified in many types. Okay, how it was classified? Now we'll see that. So you tell me how the organic compounds classified. You already studied, no? In the school they are teaching, no? Tell me. How you will classify?
Saturated and unsaturated. Saturated and unsaturated.
Saturated or unsaturated? That way, one way. Then first you can classify open chain or acyclic, closed chain abdelina or ring, or otherwise cyclic. So that cyclic compound you are again classified into homocyclic. Homocyclic means carbon containing cyclic. Okay, and heterocyclic. Again, it can be classified two types: alicyclic, aromatic. So aromatic la benzene type, benzenoid, and then non-benzenoid. For example, open chain compound means hydrocarbons. All hydrocarbons. What are that? Alkane, alkene, and alkyne. Closed and ring means homocyclic, heterocyclic. Heterocyclic means so the cycle which will contain the hetero atom. So you can have the X. X may be nitrogen, NH, or S or O. So in the cyclic form, you are introducing one hetero other than carbon atom. Okay, that's why we are saying it as heterocyclic compounds. Here நீங்க வந்து aliphatic எழுதக்கூடிய acetone, aldehyde, anything which are open chain, straight chain எழுதுறது எல்லாமே aliphaticல எழுதலாம். Alicyclic are closed இருங்க இது வரும் heterocyclic compounds எழுதுறச்ச இந்த மாதிரி then இந்த மாதிரி எழுதலாம் pyridine இந்த மாதிரி compounds. Homocyclic carbon contained எழுதுமோ alicyclic சொன்னா cyclopropane, cyclobutane, cyclopentane, cyclohexane. 6 கார்பன் வந்து ஹெக்சேன் 3 இருக்குது. அதனால 3 கார்பன் with a ring, cyclopropane, cyclobutane, cyclopentane, cyclohexane. So 7 கார்பன் cycloheptane. That also we can say. And the aromatic compounds la benzenoid compound, non-benzenoid compound. Benzenoid compound means which will contain the benzene ring. This is called benzene. Okay, when you have the benzenes like structures, the compound aniline, phenol, anthracene, So these are the example for benzenoid compound. Non-benzenoid compound means, so it will like benzene, but it is not at all. It's a type of benzene. இது நான் பென்சனாய்டுல. அதுக்கப்புறம் propylene cation, but it's aromatic. அதுக்கப்புறம் இந்த மாதிரி காம்பவுண்ட்ஸ், இதெல்லாம் aromatic compounds. Okay, non-benzenoid compounds we are call it as. Okay, this is how we are classifying our organic compound into this type. இதுல வந்துட்டு நீங்க double bond, triple bond எது வேணா introduce பண்ணிக்கோங்க. எல்லாமே alicyclicல வரும். So only carbon which is having na அது alicyclic. Aromatic சொன்னோம்னா aromaticனா என்னன்றது next lessonல நம்ம இந்த லெசன்லயே பாப்போம்னு நினைக்கிறேன். ஓ அக்குல் ரூல், அக்குல் ரூல் இந்த லெசன்ல வருதா? Okay. So is it clear, Ba? Is it clear?
Yes, sir.
Any doubts?
No, sir.
Is it clear or any doubts?
No, sir.
Okay, I will proceed further. Then I will ask one day questions that day we are going to struggle. See. And then we are going to see the functional group. So what is functional group? So functional group means an atom or group of atom joined in specific manner which are main responsible for the chemical reaction. Okay, so when you are taking the or one set of compound which having the functional group, that part only very much reactive with other things, so it can lead to give you different compounds. So that group is called functional group. So we have writing alkane, alkene, alkynes. Alkane means carbon carbon bond, carbon hydrogen bond only there, so there is no difference, so there will not be any functional group. But alkene means it will contain carbon carbon double bonds, so that double bond also behave as a functional group. Any reaction undergoing under the double bond means we are saying that is the reactive part. So in the compound, which part will be the responsible for the chemical reaction, that part is known as functional group. So what are the functional groups which is available in the organic compounds? We'll see many functional groups, starting with Fg functional group, starting with alkyl group. So what is alkyl group? When the halogens are attached, these are the things you have studied in your 10th standard, it seems, right? When halogen attached means that is alkyl group. And then alcohol. So I have written one hyphen with OH. That hyphen, it may be we have studied alicyclic, benzenoid, non-benzenoid, heterocyclic, open chain. That group may contain here, but this is the functional group. Alcohol, and then ether. Ethers means the oxygen which is attached with two carbon chain, that is known as ether. And then carbonyl compound. That means it's going to have the C double bond O. So what are the carbonyl compounds? Number 1, aldehyde. Number 2, ketone. Aldehyde means C double bond OH. Ketone means C double bond OH. And then next to the carbonyl compounds, which is known as carboxylic acid. Why carboxylic acid? No, acid means H2SO4 is acid, HCl is acid, HNO3 is acid, H3BO3 is acid. So they are called mineral acid. When the compound which contains COOH group, then it is called carboxylic acid. The compound which is contains COOH group is called carboxylic acid. And then from here, from the carboxylic acid, it has many derivatives. That is acid halide. And then ester. Ester we can write separately also. Ester. And then acid anhydride. So okay, first we'll write acid derivative by acid anhydride. Amide. And then ester. ஏன் இது வந்து sub point போடுறோம்னு கேட்டீங்கன்னா in the carboxylic acid when react with one more thing it will form an acid anhydride. When the two carboxylic acid combine, acid anhydride. When the carboxylic acid combined with amine, amide. Carboxylic acid combined with alcohol gives ester. So look here, acid halide means it will give COS. So how it will be? When the RCOOH acid react with HX. You take HX or PCl5, PCl3 or anything or PCl5. So what happened? It will be cleaved PX5. We will put. So the X will come over here and PX3 come over here and X will go. So it gives RCOX plus POX3 plus HCl. So that RCOX only acid halide. Clear? Could you see that? Could you see clearly? And then when you take acid anhydride means COOH, two acid you are taken. When you are heating, it will remove water. So it gives COO. So that R group will come. So when you have acid anhydride means it will contain COO. The remaining will be the group. Here X will be the chloro, bromo, iodo. இதனால இருக்கலாம் fluoro வராது. Amide means CONH2. இது எப்படி கிடைக்கும் அப்படின்னு பார்த்தீங்கன்னா when you have carboxylic acid COOH react with amide ammonia. So இது டைரக்டா ரியாக்ட் ஆகாது. இதை என்ன பண்ணுவாங்கன்னு கேட்டீங்கன்னா PCl5 ஓட போடுவாங்க. PCl5 or SOCl2 or PCl3 ஓட போடுவாங்க. it will give RCOX COCl. இது கூட அம்மோனியா போடும்போது RCONH2 கிடைச்சு. அவ்வளவுதான். இதெல்லாம் வந்து ப்ரிப்பரேஷன். ஒவ்வொரு லெசன்லயும் நீங்க இன் ஃபியூச்சர்ல படிக்கும் போது இதுதான். அடுத்து எஸ்டர் அப்படின்னு சொன்னா the group will be RCOO-. பாருங்க இது வரைக்கும் தான் அது எஸ்டர். அது எப்படி இருக்கும்? when you have the carboxylic acid COOH plus alcohol ROH என்ன ஆகும்? இந்த OH இந்த OH சேர்ந்து போயிடுச்சுன்னா RCOOR. So in the R group from alcohol, in the R group from acid. So this is carboxylic acid. Clear?
Understood.
Clear.
Understood, sir.
Any doubts?
No, sir.
No doubts, right? Next. இது எல்லாமே functional group interconversionல ஒரு group இன்னொரு group மாறுது. So where it will be useful no when you are doing the conversion. So you have to prepare alcohol from acid ester. Yes, we can prepare. So you have to prepare alcohol from acid. Yes, we can prepare. இதெல்லாம் வந்துட்டு அடுத்தது. Okay. Then nitrogen compound. organo nitrogen compound. So first, nitro compounds. That means nitro means you know that NO2. So NO2s are more stable than NO. Nitroside விட NO2 stable. அதனால தான் NO2 போடுறோம். ஓகேவா? And then amine. Second, amines. Amines என்னதும் திரும்ப அதல என்னது A, primary amine. B, secondary amine. And C, tertiary amine. And D, quaternary. So இது வந்து function group தனியா படிக்க மாட்டோம், but we can form the quaternary salt also. Primary amine NH2, secondary amine NH, tertiary amine N. That's all. And then nitriles. Or C1N. வேற ஏதாவது நம்ம விட்டுட்டோமா? வேற ஏதாவது விட்டுருக்குமா? உங்களுக்கு தெரிஞ்சு வேற ஏதாவது விட்டுருக்குன்னா? Carbohydrates. Yes. Yes, Rhea.
Ketone, sir.
Ketone எழுதியாச்சு fourthலயே. Aldehyde and ketones. Carbonyl compounds already போட்டாச்சு.
Okay.
So carbohydrates which contain oxygen CH2O X times. It will be a carbohydrates. வேற ஏதாவது விட்டுருக்குமா? amide எழுதியாச்சு, acetamide எழுதியாச்சு, everything we have written. Okay. These are about your organic compounds. Tomorrow means next class, we are going to see the polar effect. See, when you are looking at the organic chemistry, if you know the polar effect, then it could be very, very, very important and essential. Because when the carbon bonded with some other atom means some of the bonds are polar, because there will be electronegativity difference. Some of the bonds are not at all polar, they are electronegativity same. Then how the reaction is going? So what are the type of organic reaction and how the reaction is going? How the factors when you're taking formic acid, acetic acid, formic acids are more acidic than acetic acid. Both are contain COH group only, but the formic acids are more acidic than acetic acid. Why it's so? Then when you're taking carbon-carbon double bonds means generally it will undergo addition reaction. Whereas the benzene having 3 carbon-carbon double bond, but it undergoes substitution reaction rather than addition reaction. Why the benzene undergoes substitution reaction? What is the reason behind that? Why the benzene will get the extra stability? If you want this answer, and then when you are taking benzene and benzaldehyde and toluene, you are doing oxidation, you are doing chlorination. The toluene will undergo chlorination faster rate than the benzene, which in turns more than the benzaldehyde. The benzaldehyde will go slower rate than benzene. Why so? So which will control this? It has to undergo faster rate, it has to undergo slower rate. So some of the factor which influence the reaction. Okay va? Other நம்ம போய் எதை பத்தி பார்ப்போம்னா when you are studying polar effect you come to know. Is it okay?
Okay, sir.
Is it okay? So this is how we have to do that. Next class we will do that. சரியா? Next class என்னைக்கு இந்த schedule போட்டாங்கன்னா அன்னைக்கு பண்ணலாம். Now you go and join the mathematics class.
Thank you, sir.
Okay?
Thank you, sir.
Okay.